Did you know that the Bitcoin white paper is just 9 pages long? But it has the potential to become the rails of the financial ecosystem. In today's video, we will look at snippets from the Bitcoin white paper. We'll look at the concept of peer-to-peer transactions proposed by Satoshi Nakamoto, and then we will touch upon the concept which proposes a network server that timestamps transactions by hashing them into an ongoing chain of hash-based proof of work. I would highly recommend that you watch my videos on what is blockchain and what is Bitcoin. This will provide you the foundation to begin your investing journey in cryptocurrency. For those who are new to me, we run the portal thetwig.com, which is what you are seeing here. This is primarily focused on investing on shares, options, futures, and crypto. I just want to put a caveat here. I'm not a financial advisor. This content is for educational and entertainment purposes only, and we do recommend that you do your own research before you make any investment decisions. So let's dive right in and look at the Bitcoin white paper. So as you see here, the Bitcoin white paper was titled Bitcoin, a peer-to-peer electronic cash system, and it was released in 2008 by Satoshi Nakamoto. You can see this Bitcoin white paper in bitcoin.org. It was sent by the email ID satoshiin@gmx.com. Now, what I've done for the listeners like you is articulated some of the key points in the white paper through this blowout bubbles, as I like to call it, to give emphasis on what he really talks about. See, this white paper is pretty simplistic. It's a 9-page document, but very powerful in what it conveys, and it has become the foundation of the Bitcoin and the blockchain industry. Here in this white paper, he talks about the concept of how an electronic cash payment could be done peer-to-peer. When I say peer-to-peer, it means from one person to another without the intervention of a financial institution. He suggested that this can be achieved by time-stamping transactions. So if I send money to somebody else, each of those transactions gets recorded. The time of the transaction also gets recorded. So he went on to say that this recording of transactions can be done by a network of computers. These network computers add those transactions in a sequential fashion, one after the other. And these transactions are secured using something called as cryptographic hash function, in this case SHA-256. And I have talked about SHA-256 in the video What is Blockchain? I can provide a link in the description below. So this process of securing the network transactions and connecting them like a chain, it requires lots of CPU power by the nodes within that computer network. So this process is called a proof of work. The process of hashing, which requires the CPU power, is called the proof of work. And if you look here, what Satoshi goes on to say is the network timestamps transactions by hashing them into an ongoing chain of hash-based proof of work. This forms a record that cannot be changed without redoing the proof of work. The solution that Satoshi Nakamoto proposed is using a timestamp server, which is what is represented here. Satoshi here says a timestamp server works by taking a hash of a block of items to be stamped and widely publishing the hash. So here you see the items, multiple items in a single block, and that block has been hashed. Similarly, another group of items formed a block, and that block has been hashed again. This block, the second block, has the hash of the previous block, and that's how each of those blocks are chained together. So Satoshi Nakamoto's white paper is brilliant in its simplicity. Here what he does is he explains what a proof of work is. He says a proof of work involves scanning for a value that when hashed, such as with SHA-256, the hash begins with a number of 0 bits. So let's understand this with this example of the block that he has shown here. So what you see in this block are three different things, right? One is nonce, which is a number which is used only once to generate the hash. Then you have the hash number, and then the transactions within that particular block. For the timestamp network that Satoshi Nakamoto was proposing to implement electronic peer-to-peer payment, he suggested having a proof of work mechanism. What does this proof of work means? So he was suggesting implementing the proof of work by incrementing the nonce in this block until a value is found for the hash, for the block's hash, with the required number of 0 bits, which is the difficulty level. So Satoshi Nakamoto goes on to say in this white paper that once the CPU effort, once the network, the nodes within the network have spent the effort to satisfy this proof of work, which is creation of the hash for this block, so the block cannot be changed without redoing the work. And why is that? Because the hash of that block is dependent on the nodes, and it's also dependent on the transactions within that block. So the moment you change any transaction, it means the hash of this block has changed. And since the next block has the hash of the previous block, uh, the moment the hash of this block has changed, this next block is no longer connected because the number, the previous hash, is a different number compared to this hash. And Satoshi Nakamoto then goes on to say this: to modify a past block, an attacker would have to redo the proof of work of the block and all blocks after it. So this is how Satoshi Nakamoto describes the steps in the process of creating the transactions and recording it within the blockchain. He says that any new transaction are broadcast to all the nodes. So the entire network has information about a transaction. Each node collects new transactions into a particular block, and then each node works on finding. So all the nodes within the network, they start on working on finding a difficult proof of work for it, that block, which is the hash number. When a node finds a proof of work, it broadcasts to the block to all the nodes, so that every node within the network can verify that this is the correct block. So nodes accept the block only if all the transactions in are valid and not already spent. The nodes express their acceptance to the block by working on creating the next block in the chain, using the hash of the accepted block as the previous hash. So in this process, they also consider the longest chain to be the correct one, and you will keep on working on extending it. So for all of you listeners who have gone through my video on what is blockchain and then what is Bitcoin, I'll provide a link down below in the description. You will realize that this white paper is so simplistic in its nature, right? In just 9 pages, and I have just looked at some snippets of that information. He clearly articulates as to how the entire blockchain would work. So let's see this as an example, right? Where he talks about an incentive. What he goes on to say is, by convention, the first transaction in a block is a special transaction that starts a new coin owned by the creator of the block. This adds an incentive for nodes to support the network and provides a way to initially distribute coins into circulation, since there is no central authority to issue them. And this is how the cryptocurrency is created. This is how Bitcoin was created within the blockchain network, and the nodes within the network are supporting it. So what is supporting the blockchain network is the computer nodes within the network. And what are they spending? They're spending the CPU time and electricity to generate uh, those coins. And as rewards, the computers which are involved in generating the hash or doing the proof of work get the reward or the incentive. Satoshi's addition in enabling peer-to-peer electronic cash transaction between two individuals without the involvement of financial institution is very simplistic in its execution and in its articulation as well. The final two things he talks about is privacy, and then finally why the system itself is robust enough and it's sort of tamper proof. So he gives the example of how this system enables privacy. He goes on to talk about the traditional banking model vis-a-vis the new privacy model. He says the traditional banking model achieves a level of privacy by limiting access to information to the parties involved in the trusted third party. So what you have in a traditional privacy model, you have identities, you have the transaction that happens, you also have a third party who is involved and the counterparty. And this information is not shared with the general public. But in the new privacy model, what he's suggesting is identity of the person who is doing the transaction will be protected, but the transaction itself will be shared by the public so that it's verifiable. Finally, in his white paper, he also talks about, he gives a calculation which we'll not delve into, but how if somebody wants to overtake the network, a bad actor or a bad node or computer wants to overtake the network, it's so difficult because The network is based on lots of computers working together, and at least 50% of them validating and ensure the system is working fine. And since the network is chained together, it's very difficult for a dishonest node to be able to catch up with the honest nodes. Finally, to conclude his white paper, he goes on to say, to solve this problem of electronic transfer, he suggested a peer-to-peer network using proof of works to record a public history of transactions. The transactions are public, that quickly becomes computationally impractical for an attacker to change if honest nodes control a majority of CPU power. As long as more than 50% of the nodes are honest, the more than 50% of the nodes within the blockchain network are empowering the system will function smoothly and without any hassles. They vote with their CPU power, expressing their acceptance of valid blocks by working on extending them, and they reject invalid blocks by refusing to work on them. Any needed rules and incentives can be enforced with this consensus mechanism. That was brilliant. That's it for today. Hope you liked the video. I'll leave you with a question for today. Do you think that Bitcoin is here to stay? Let me know with your comments down below. Hope to see you again. Cheers.